So in this problem, we have a 263-foot lighthouse. A plane is sighted overhead, and a ship is observed directly below the plane. Okay, so let's start with the ground, which I suppose is, here's the water, is blue. We'll do the grass is green here. Okay, so the lighthouse is right here. For simplicity, we'll keep our picture very simple. Call that the lighthouse. Okay, and its height is 263 feet. Now it says a plane is sighted overhead. The plane is going to be higher than the lighthouse, so let's assume there's my plane. And a ship is observed directly below the plane, so way down here. Let's go ahead and draw the line actually. There is a ship. Okay. The angle of elevation of the plane is 26 degrees. I think that implies that if you're in the lighthouse and you're looking up at the plane, that would be your angle of elevation right there. That's 26 degrees. And the angle of depression of the ship is 41 degrees. And those are right angles there. Find the distance of the ship from the lighthouse. That would be this distance down here, the blue line. And B, the plane's height above the water. Okay, so first I'll start with the ship's distance from the lighthouse, and we'll call that X for simplicity. We have lots of triangles to choose to use for this. We want this ratio X, so I'm going to use this triangle here because I need to include that distance X. Another way to do it though would be to realize that the distance X is the same as this length right here. Okay, and use the triangle that we've already drawn. That would work as well, but it's okay. So right here, if we're going to use this X, we need to find this angle or both. So if this is 41 degrees, we know they add to 90. So this one would be 49 degrees. Okay, then let's see. We need to relate the two known angles, or one known angle and one known side, to this unknown side X. Now we know that the height of the lighthouse is 263, and it's the side adjacent to this 49 degree angle. So we could use a trig ratio that will relate the adjacent side to the opposite side from that angle, and that trig ratio would be tangent. So we can say tangent of 49 degrees is equal to the opposite side X over the adjacent side, which is 263. So to solve for X, we just need to multiply both sides by 263. So we'll get X is approximately equal to 263 times the tangent of 49 degrees, which you can approximate in your calculator. So that's part A. Then for part B, the plane's height above the water, well, that's the sum of this distance. I'm going to call that, let's call it Y1, and we'll call this distance Y2. I think we're going to need to find those distances separately and then add them together. Okay, now actually Y1 we are given. If you recognize that this is a rectangle here, so that distance is 263. Then to find the height from the top of the lighthouse, really this imaginary point out in space here, directly up to the plane, we can use this triangle. And let's see, we now know X, so it looks like we're going to need to go ahead and approximate that value of X in order to find part B. So let's do this approximation. 263 times tangent of 49. So I'm going to do 49. This calculator is in degrees, so I'll take tangent, multiply that times 263 to get 302.5469. 302.5469. And that's in feet. There's supposed to be a 3 there. Okay, so we can use that value right here, this is about 302.5, and I'm not going to round when I reuse the number. Okay, so now I need to set up a trig ratio. I'm going to go with this triangle here. So which trig ratio relates 26 degrees, its opposite side, and its adjacent side? It's still tangent, so tangent of 26 degrees is equal to its opposite side, which I labeled y2, over its adjacent side, which is this 302.5469. So then y2 is equal to the product, multiply both sides by 302.5469, and then that's times the tangent of 26 degrees. Let's see. So that, anyways, you can approximate that in your calculator. I don't really need to do that. And then your answer in part B is going to equal, let's see, the plane's height above the water is the sum. So remember to add 263 to the value of y2.